So we're thinking of this composition as an operation on functions. We have operations on numbers, addition and multiplication, and those operations have certain properties. So for example, if I look at addition of real numbers, it's associative. That is, if I'm adding three numbers together, I can group the first two, or I can group the last two. And it's commutative. If I'm adding two numbers together, I can add them in either order. And these properties are really nice. They let us be kind of sloppy with how we write addition, right? If we're adding three numbers together, we can just write 2 plus 3 plus 7 with no parentheses, because it doesn't matter how you group them. And generally when we're writing, say, a variable and a number added together, we'll prefer to write x plus 2 rather than 2 plus x, since they mean the same thing and it's nice to have a standard form. Multiplication of real numbers has those same properties, which lets us get away with the same kind of sloppiness. Now we have this new operation, something that we do not to numbers, but to functions. And we might wonder, all right, does this new operation on functions have these same nice properties? There's good news and there's bad news. Composition of functions is associative, but it is not commutative. So I'm not going to prove to you that it's associative. I'm just going to demonstrate it in one specific example. I am going to prove to you that it's not commutative, simply by showing that composing functions in opposite orders gives us different results. To see composition being associative, we need to look at three functions and think about what happens when we compose them together. We'll see that if we take f composed with g and then compose that with h, we get the same result as if we take f composed with the result of g composed with h. So let's see, f composed with g of x, that'll be f of g of x. G of x, that's just 2x, so f of 2x. So that'll be, f is the function that takes its input, 2x in this case, and adds 1. So f composed with g of x, that's 2x plus 1. So f composed with g composed with h of x, right? That's f composed with g of h of x. H of x, that's just x minus 3. So I want to take f composed with g of x minus 3. What does f composed with g do? Well, that takes its input, multiplies it by 2, and adds 1. Its input, in this case, is just x minus 3. Simplifying that, we get 2x minus 6 plus 1. Combining like terms, that's 2x minus 5. Okay, so this left-hand side, f composed with g composed with h of x, that's 2x minus 5. Okay, now the other side. G composed with h of x, well, that's g of h of x. So that'll be g of x minus 3. G of x is the function that takes its input and multiplies it by 2. In this case, that input is x minus 3. Simplifying, we get 2x minus 6. Then f composed with g composed with h of x. Well, that'll be f of g composed with h of x. So that'll be f of 2x minus 6, which is what we just found out that g composed with h is. So that'll be 2x minus 6, f takes that and adds 1. Okay, simplifying that by combining like terms, we get again 2x minus 5. Again, that doesn't prove that composition is associative. We might just have luckily stumbled upon 3 functions for which this works. But it is at least a demonstration of what associativity means in this case. And in fact, composition is associative. With any 3 functions, this will work. On the other hand, it's relatively easy to pick 2 functions that demonstrate that composition is not commutative. For example, if we take as our 2 functions f of x is x plus 1 and g of x is 2x, as before, then f composed with g, that'll be f of g of x, so f of 2x. F is the function that takes its input and adds 1. So f composed with g of x is 2x plus 1. On the other hand, if we take g composed with f, that'll be g of f of x. So it'll be g of, well, f of x is x plus 1. What's g? G is the function that takes its input and multiplies it by 2. In this case, the input is x plus 1. Applying the distributive property, we get 2x plus 2. G composed with f of x is 2x plus 2. These are clearly different functions. Any input we give will generate different output. So it's important to keep in mind that order does matter in composition. Composition is not commutative. G composed with f, f composed with g, they will in general be different functions. And that's going to matter most of the time when we're working with these composite functions. So it's something to keep in mind.